What are Newton's three laws of motion and how are they useful in daily life? Newton's first law of motion. Newton's first law of motion states that an object will remain at rest or in uniform motion at a straight line unless acted upon by an external force. This law is often referred to as the law of inertia. Inertia is the tendency of an object to resist changes in its state of motion. As you might have already seen this in a car, when a car suddenly stops, you tend to lurch forwards. This is because of the law of inertia. If you want to know more, I have already made a video about it, so you may go and watch it out. Now let's get back to the point. Examples in daily life. When a soccer ball is kicked on a frictionless surface, it will continue moving at a constant velocity until it is acted upon by an external force, such as friction with the ground or air resistance. An example of this is a spaceship which orbits the Earth. When a spaceship orbits the Earth, it keeps moving with a constant velocity because there is no resistance force like air to stop its motion. This is an application of Newton's first law in the context of orbital mechanics, where the gravitational force between the spaceship and the Earth keeps it in motion. Newton's second law of motion. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This law quantitatively relates the force applied to an object, its mass, and the resulting acceleration. Mathematically, it is expressed as F equals to m into A, where F is the force applied on the object, m is the mass of the object, and A is the resulting acceleration produced. This law helps explain how objects respond to forces and how their motion changes as a result. If you push a shopping cart with a greater force, it will accelerate more. This is because the force applied to the cart is directly proportional to its acceleration as per Newton's second law. Similarly, a lighter shopping cart will accelerate more with the same force compared to a heavier one, demonstrating the inverse relationship between mass and acceleration. Another example of Newton's second law of motion is driving a car. When you are driving a car and press the gas pedal, the car accelerates forward. The amount of acceleration depends on the force exerted by the engine and mass of the car. Newton's second law helps explain why heavier cars require more force to accelerate compared to lighter ones. Newton's third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. This means that when one object exerts a force on another object, the second object exerts an equal and opposite force back to the first object. This law is essential for understanding interactions between objects and is crucial in fields such as mechanics, aerodynamics, and rocket propulsion. Examples in daily life. When you swim, you push the water backward with your arms and legs, and in response, the water pushes you forwards. This is an application of Newton's third law in fluid dynamics. And another example can be when you walk on the ground, your foot exerts a force backwards on the ground, and the ground exerts an equal and opposite force forward on your foot, propelling you forwards. This action-reaction pair allows you to move forward while walking and is an example of Newton's third law applied to human motion. Thank you.